Hi, I'm Shiv, and today we're going to be talking about how Google Maps actually work. Okay, so let's go back a few years. Let's go back to, say, the 2000s. You want to go from point A to point B. What will you do? You'll take out your trusty old paper map, you'll plot point A, you'll plot point B, and you'll make the path between point A and point B. Yes? Now, how did Google take this process to Google Maps? So obviously there are four main components in this process. The first being your map, the second being point A, the third being point B, and the fourth being the path. Okay, so point A is the starting point. So let's take out your phone. In Google Maps, the starting point is the location of your device in most cases, yes? Point B is the destination. So you enter that. So we have point A, we have point B. Now let's talk about the map. Okay, so to get the map, so Google Maps started a journey by buying this company called Where2 Technologies. Now it was a mapping-based company. Now Google needs data about the various countries in the street layouts. So what it did, it contacted local and global institutions for information regarding the roads, the highways, and all of that stuff. And unfortunately, like these institutions, they do have data, but they don't have like complete data, or sometimes they don't have the data at all. So Google went for the second approach, which was satellite imaging. Yes, so it took a satellite. Suppose this is a satellite image and this is a maps image, and well, this is a satellite map image. So it can use the satellite image to generate map images. And for example, on Google Maps, you can see the outlines of buildings when you're traveling. That is also done using satellite imaging. Okay, so the next step Google took was Street View. Wait, isn't Google Street View like used for Street View? I mean, it is obviously used for that, but it is also used for verifying the information that we have from the previous sources, and reading the street road symbols and giving you more accurate, giving you a better experience while using Google Maps. The next approach it used was crowdsourcing. So what does crowdsourcing mean? Crowdsourcing means me, the user, we are volunteering, we are sourcing this information to Google. So say I'm a local businessman and I want to showcase my business in Google Maps. So I'll register with Google Business and I'll put the location of my business on the maps. Yes. Or for instance, you're traveling in a road and you see construction work. So you can report that there's construction work going on here. Or there's an issue with a particular path. You can report that issue and Google will like look into it. Yes, so that's called crowdsourcing. And the last approach it uses is, well, Google is a database company. Yes. So the last means of information it uses is, well, you. So all the location data that you have while you're traveling using Google Maps, that is all analyzed, and that's also used to give a better experience while using Google Maps. Okay, so now we have the map, we have point A, we have point B, and all we need is the path between point A and point B. How that's done is it's done using algorithms. Yes, so Google mainly uses two algorithms. The first one is called A-star algorithm, and the second one is called Dijkstra's algorithm. So let's talk about those algorithms now. And if you want to skip the technical parts, you can click on the timestamp here and you can skip them. So yeah, so let's go. So hi, now I'll give you a quick context for the rest of the part of the video. So we're going to be talking about nodes a lot now. What are nodes? So as in the video you saw that we have the map, we have a point A and we have a point B. So every decision that you have to take when you are traversing from point A to point B is a node. So you reach till here and you have a choice, where do I go? This is a node. You have another choice, where do I go? This is a node. Okay, now that that's done, let's talk about how are we actually gonna go from A to B. Well, I'm a computer, suppose, and then according to me, when I'm at this decision, I have no information about anything that lies further from here. Okay, so how are we gonna do this? So the three obvious methods. The first being a brute force method. We start from the starting point, we explore all the avenues, and we only stop when we reach the destination. As you can see, we just keep going in a circle and expanding until we get to the destination. This is also referred to as a breadth first search. Okay, the second approach is a greedy method, aka the Dijkstra's algorithm. So a quick reminder for Dijkstra's. How Dijkstra's works is that, well, suppose you're at A, which is the starting node, and you have to get to F. Okay, so you see the next possible nodes, which is B and D. The distance from A to B is 1 and A to D is 10. So Dijkstra's has the simple principle: you take the shortest path, you take the least possible cost. Okay, so we'll choose 1, we'll choose B as the next node, and we'll keep doing this for all the nodes and updating the values in every run, or relaxing the values. Okay, so yeah, so that's the greedy method or Dijkstra's algorithm, where we're focusing on lowering the cost. Third is greedy plus heuristics, which is the A-star algorithm, aka the Google Maps algorithm. Okay, so I'll get to what this heuristics is in a bit. So this was how brute force look like. Okay, and this is how Dijkstra's looks like. We're prioritizing the least possible cost. Okay, and this is how A star looks like. In A star, we're not only prioritizing the least possible cost, but we're trying to ensure that we're going towards the destination. So the variables or the factors that we'll use to find out are we actually going closer to the destination is, well, heuristics. Okay, so let's talk about A star. All of A star can be summed up in the single formula: Fn equal to Gn plus Hn. Okay, so what is this again? So Fn is your total cost. Gn, okay, Gn is the cost from your source node to the next node. So in this instance, Gn is the cost from A to B. This is Gn. A to D. This is Gn. I'll just call it Gn dash. Okay, and what is Hn? Hn is the heuristics value. So for this explanation, we're going to use the simplest form of heuristics, which is Euclidean approach. I'll get to what that is again. So what we'll do is, okay, you'll be seeing A to B, and it's the distance from B to the final node. Well, it's 15, and the distance from D to the final node is 4. So we total them up. 15 plus 1, 16, and 10 plus 4, 14. So we'll choose A to D because that will take us closer to the final node. Okay, so that is what A star is. Now I mentioned something about this Euclidean method. So Euclidean method is just a fancy way of saying that, well, we're finding the distance, the direct displacement from the node that we're trying to find out which node are we going to, till the final destination. And obviously the formula for that is x2 minus x1 whole square plus y2 minus y1 whole square whole root, where x1, x2, y1, y2 are the coordinates for the node and the final destination. Okay, so we've done a bunch of stuff now. How does this actually affect our calculations? Is it worth doing so much that we've done? Well, you can see the differences. The first photo is for Dijkstra's algorithm. The blue sections, the blue tiles, are the tiles that the computer has traversed through. And the second photo deck you can see is for A-star algorithm, and as you can see, we have drastically decreased the load on computation power.
Alright, so if you've reached till here, thank you for watching the whole video. I hope I didn't bore you, and I wish you have a fabulous day ahead. Thank you, bye.